Hi folks, today we are adding another LCD driver to our collection. This time, the driver comes from ROM Semiconductor with the reference BU97520AKV. This driver supports 4 command lines, or 4 COM lines, with 69 segments on each one. That gives us the ability to control up to 276 segments. The driver is installed on the front panel of a GVC car radio, model KDX230. Unfortunately, we were only able to locate the service manual for the X220 model. Even so, that documentation was already a great help during the analysis process. Since this is a driver from around 2015, it includes several advanced features. For example, it allows the use of pins configured as GPIO, including support for PWM functions. It also supports the control of a keyboard matrix with up to 30 buttons. Controlling this LCD is not especially easy. One of the biggest difficulties was the fact that it was not possible to establish a clear pattern between each 14-segment digit. Because of that, we ended up identifying the segments manually, without relying on automated code routines. The transmission process works as follows. First, we send the driver address, which in this case is 0x42 for writing. After that, we send a block containing 96 bits. The last 2 bits define the block order. There are a total of 4 blocks identified as 00, 10, 01, and 11. Since we decided to use the default configuration, which is 1/4 multiplexing, this may not have been the ideal choice for implementing the display. Even so, the proof of concept was successful. As usual, we did not spend time creating a complete character library. Such a library would only work correctly for this exact hardware configuration. Instead, we created only a few characters and symbols to animate the display. Another difficulty comes from the fact that the data blocks are not uniform. The first block supports 72 segments plus 22 additional bits and 2 control bits. The second block supports 84 segments plus 10 additional bits and 2 control bits. And both the third and fourth blocks support 60 segments plus 34 additional bits and 2 control bits. In every case, the final size of each block is always 96 bits. The control bits themselves are distributed throughout the 4 blocks, and depending on the active configuration, some of those bits may also control display segments. Even though the structure initially appears complicated, the driver becomes much easier to use once the concept is understood. The code includes examples for to text messages, all segments turned on, and all segments turned off. There is also an example demonstrating the backlight dimmer function, as well as the control of the red LED illumination on the panel. The red LEDs are activated through a power-up signal of 10.5 volts applied to pin 6 of connector CN1. Regarding the keyboard, only a simple function was implemented to read the state of the buttons. This function can easily be adapted to suit different projects. One important detail is the configuration of pin 8 inside the read buttons block. This pin changes between input pull-up mode and output mode during operation. It is also important to note that the reading address used by the driver is 0x43. To connect the 2 lines coming from the panel, we use 2 470 ohm resistors and then connected them to pin 8 of the Arduino. According to the manufacturer, the driver supports supply voltages from 2.7 volts up to 6 volts maximum. In the schematic of the X220 model, the driver supply appears regulated through a transistor combined with a Zener diode configured for 5 volts. However, an interesting detail is that on this particular panel, I could not locate the regulation stage for 3.3 volts, nor the infrared receiver section. For communication, we use the standard lines: data in, data out, clock, chip enable, and the INH pin. In this code, the INH pin is kept high through pin 11 of the Arduino. However, it would also be possible to use a 2.2 kΩ resistor, saving one Arduino pin. And, as always, it is essential not to forget the common ground reference between the panel and the microcontroller. After implementing everything described here, the panel is fully operational and ready to be reused in new projects.